Hello. In this video, I'm going to talk about activity selection problem. Activity selection problem. We will be having n number of activities, each with a start and finish time. Our goal is to find the maximum number of activities that are compatible with each other, which means which are not overlapping with each other. For this, to solve this, I have used two algorithms. One is greedy algorithm and the other one is dynamic programming. In greedy algorithm, we always make the choice which seems best at the current moment. While in dynamic programming approach, we divide the problem into n number of subproblems and solve each subproblem to get the final output. Now let us move to the code. In this code, I have taken the input sizes as 7,000, 8,000, 9,000, 10,000, 20,000, 30,000, and so on till 70,000. For generating the input, I have created two lists, start and finish, and then used the random module to get the values and store them in these two lists. Then I have merged these two lists into a list named merged list. Later, I have given this merged list to a algorithm which I have used for sorting, and for writing this algorithm, I have used the technique merge sort. Later, the output from this sorting algorithm is given to our algorithms. In greedy algorithm, I have created one special list known as solution. I have added the first list from the sorted list to this solution and start comparing the values of finish and start times of the current activity and the next activity. If the start time of next activity is greater than or equal to the finish time of current activity, then I have added that activity to my solution list. And then I have started checking the current activity in the solution with the next activity of the sorted list. By the end, I had a set of activities which are compatible with each other. And this count gives me the maximum number of activities which are compatible. Coming to dynamic programming approach, I have created two lists, P and M. P stores the index of rightmost activity that appears before the current activity and is compatible with the current activity. I have written M using memorization technique. In memorization technique, we solve the subproblem and store the value in a list. This way, we can save some computation time as we don't have to repeat the solving for the subproblem again. Now let us run the code to see the output. For running the code, now I am giving the input as sum 50. Here I got a sorted list of 50 activities. Now my solution from the greedy algorithm is that we have 6 activities which are compatible with each other, and this 6 is the maximum number of activities. Even dynamic programming gives me the same number. While greedy algorithm took some amount of time, the dynamic programming technique took a time which is greater than the greedy time. The algorithm runs on O of n equal to n log n, whereas the dynamic programming runs on O of n equal to O of n square. I have created some graph to compare the runtimes of these algorithms. For the greedy algorithm, if we compare the empirical runtime and predicted runtime, we can see that it is almost similar. Also, the the same with the dynamic programming. Here also, the empirical runtime and predicted runtime are consistent with each other. Now, I have compared greedy and dynamic programming runtimes. We can see that as the input increases, dynamic programming is taking more time to solve the problem. So, we can conclude that for this particular problem, activity selection problem, greedy algorithm gives the best output. However, this might not always be the case. For our problem, we assumed that the activities have equal weights. If the activities have different weights, then greedy might not be the best and dynamic programming might be the best choice. So it is important to know the problem before choosing the algorithm. As as the scenarios changes, the best output from the algorithm changes. Thank you.